Greetings to everyone watching this video. My name is Maha Antoinette Jerome. At present, I am reading for the Master of Science in Cybersecurity and Digital Forensics program offered by the University of Westminster. This visual presentation is done as a partial fulfillment of the said postgraduate program, where I present to you about the research project area that I have chosen to undertake, which is the AI Bill of Materials Generator and Vulnerability Detector. And this project was supervised by Mr. Sitirahe Varachi, and I have also obtained the guidance of Mr. Guhanathan Poravi, to both of whom I am thankful for. For the purpose of the presentation, I'll be discussing the structure of the presentation under 5 main topics. First of all, I'll discuss about the problem background and the problem research domain that exists. And I'll give you an introduction about the research area. Then I will speak about the gaps that have been identified through various sources and how those gaps are addressed through the solution that has been proposed. And then I will do a live demonstration of the minimum viable product that has been developed for the purpose of this research. And then finally, I will discuss about the evaluation of the minimum viable product, and based on the evaluation, what are the future developments that are proposed for the product. Moving on to discuss about the problem domain that exists. I'll first talk about the software problem domain that exists. It's mainly related to the software supply chain security. So in the cybersecurity and information security realm, there are a plethora of attacks that occur and are attempted at nearly every second that we pass by. And software supply chain security related attacks has gained prominence over the recent past. And there have been very successful attacks which have occurred due to the vulnerabilities that exist within the software supply chain. Individuals and organizations, governments, everyone relies on software. Software that is built using other types of software components, dependencies. Most often than not, we who use these software, whether it's an organization or individual, are unlikely to know what are the components that have gone into build these software and what are the risks that are associated with these components that have been used. It can be software packages, libraries, frameworks that are used to build these software. We are unaware of the points of vulnerabilities, how they can be exploited by an attacker. The software supply chain security related concept emerged after two prominent attacks within the industry, mainly the Log4j vulnerability and the SolarWinds attack, which involved exploitation of the vulnerabilities which were identified in their software libraries and packages, which were used as a point of exploitation by the attackers. So the research domain that I have chosen mainly is the software supply chain security. Now, moving on from software, the ideal research domain that my scope of research involves is the AI related supply chain security. Coming to AI related supply chain security, the AI domain has been a hotbed of innovations where people every now and then innovate a lot of solutions based on the artificial intelligence models that are available and prevalent out there. And it has also, on the downside, has an expanding threat landscape where AI supply chain security attacks have been occurring and happening. You see, the news articles are evidence for those where AI supply chain attacks are happening by exploiting the vulnerabilities that exist within these AI models that are used to build AI solutions. So it is predicted by Cyber Ventures that by 2031, the industry would have to incur a loss of 31 billion US dollars because of supply chain related attacks. So the problem domain that I have chosen mainly is to research on AI related supply chain security attacks and how to circumvent those attacks as a solution. The gap that I identified, unfortunately, the research resources that are available when it comes to research papers and articles by industry veterans and academicians is very limited. So the literature review with the limited research papers that are emerging was conducted, and what has been proposed as a solution to circumvent AI supply chain attacks was a concept drawn from the software domain itself, which is the software bill of materials, which software bill of materials is a mandatory regulatory requirement, especially in the US and even in the EU continents, especially if you're doing business with their government agencies, you need, and you are a software service provider for them, you need to have the software bill of materials in hand, which explains what components have gone into developing those software, and then identifying what the vulnerabilities are, how you have mitigated them, and so on and so forth. Whereas when it comes to AI supply chain, AI related solutions, it is still emerging and there is no concrete standard or regulatory requirement that has emerged as of now. Talking about the literature review of the people who have researched on this and are still researching, which is in progress, what has been proposed is there was a conceptual framework which was not materialized, which has been developed by Barclay, one of the researchers, was developed to extend to track the dependencies of the AI related solutions, and that was a conceptual framework. Now, there was another researcher called Shea, where they presented an architecture which was based on blockchain, but mainly catering to software bill of materials. And at the conclusion of the research, they've mentioned that it can be extended to AI bill of materials, but how the extension happens has not been widely discussed within that research paper, but just the groundwork for the software bill of materials was provided in it. So there exists a gap as to, okay, if we are applying certain frameworks, how we do it to AI bill of materials is the concern. And then researchers have also discussed extensively about why the software bill of materials structure and the already generated solutions that are available cannot be used for AI bill of materials, because AI solutions are more complex. They include more dependencies and sub-dependencies, and their components are vast, and their attacks are unique to themselves. So the vulnerabilities would be unique. Therefore, the same concept cannot be exactly used, but it needs to be customized, or workaround needs to be found for a bill of materials. That was discussed. And then it was also suggested by a researcher that it is better to develop the AI bill of materials at the development phase itself, so that it is not dependent on the developer, because there might be multiple developers associated, and it is not dependent on the developer to update as and when they're using particular models or data sets for their AI solutions, and it's updated on a real time basis, and people can keep track of what the components are. So these were the suggestions that were made in the literature review and the gaps that have been identified. That the conclusion is that there is no robust solution that is available at the moment. Then, based on the interviews that were conducted with the organizations and the individuals who are using these AI solutions or developing these AI solutions in their businesses, what was understood was the current approach that the organizations, if they are to meet the mandatory requirements, was that they follow a manual approach of updating their content management systems, where they maintain the bill of materials. They maintain the solution details and the dependencies as and when they are updated. And this was mainly the responsibility of the developers or the associated project managers to do so. And it's a manual work, and there is no guarantee that it would have been updated or not. And then there is also the approach of updating these bill of materials at the commit and version control stage of the solutions itself. And that was also through a content management system that they were using. The issue that their organizations face was if they were to procure solutions, AI solutions from third parties, because most often than not, third parties would not provide something like an AI bill of materials for the solution that they are selling to the organization. So parties have to rely on the contractual obligations if there was an exploitation that was to happen because of a vulnerability that existed within the solution which was provided. Then there is also lack of real-time detection of vulnerabilities because vulnerabilities keep on updating, new attack vectors keep on emerging. So at this point of time, to identify what are the vulnerabilities of the AI solution that an organization is using, there was no proper solution available for any organization to identify that. Based on the discussions, the conferences of industry experts, and the exhibitions and the talks that were held, the main highlights of those key points were that there needs to be enhanced transparency when it comes to AI solutions, and it needs to be mandated. Because if you take the proprietary AI solutions, there is no proper documentation as to how the data sets or the models have been trained, what environments or procedures have gone into it, what kind of biases are associated. So there needs to be further transparency involved in it, and there needs to be better awareness created among the industry of the importance of AI supply chain security as well, so that people are aware that they need to be aware of the risks associated with the solutions they're using. Then AI bill of materials was proposed as a safeguard, as a countermeasure, as a prerequisite for these risks or the issues that the industry is facing, similar to the already available software bill of materials concept. And if there is an AI bill of materials, it was mentioned, quoting the example of the Log4j vulnerability when it was exploited at the time, and many customers were affected. The customers who had the software bill of materials readily available in their hand were capable of resolving and responding to that incident more efficiently, as opposed to those who didn't know which particular application or which devices or which infrastructure resources were affected and how to remediate that. So having an AI bill of materials will always facilitate the efficiency of an incident response procedure. And also, similar to the literature review, the discussion also evolved around why there needs to be something customized as an AI bill of materials as opposed to having the same concept of software bill of materials to AI bill of materials. Further discussing on the gaps, comparing the regulatory requirements and the standards that are available. So, the current status of the software supply chain is that there exist solutions. There are solutions available where organizations can go and generate their software bill of materials, and there are standards developed as to the structure of the bill of materials, what criteria needs to be involved in it. Like Cyclone DX, SPDX, and SWID are already available standards for those. And there are mandated regulations by the USA and EU to govern the software bill of materials requirement. When it comes to the AI supply chain security, the concept of artificial intelligence bill of materials is fairly new, and it's an emerging concept. It's being researched upon and being discussed widely in the industry. There is no concrete standards which are available except for the ISO 42001, but it doesn't give you a definite structure as to or structure or propose something like an AI bill of materials. And it just speaks of vendor risk management pertaining to it. And though there are AI acts that had come out, but there is nothing that speaks of the requirement of how the supply chain security needs to be managed when it comes to AI, and still being regulations are still discussed. So that is where the gap exists, where there is no proper solution to develop an AI bill of materials, understand what kind of structure it needs to have, and then detect the vulnerabilities associated with that bill of materials. Now, why can't Why do you need an AI bill of materials as opposed to why can't you use a software bill of materials? Like I mentioned previously, based on the literature review and the discussions that were held, where industry experts and researchers have spoken, voiced their opinion about it. Software bill of materials are specific to software. We know what they're made of. The frameworks, the languages, the modules, packages, libraries, and executables are known. So it's specific. And most of the vulnerability databases, all of the vulnerability databases actually target software-related vulnerabilities and their dependencies, as opposed to when it comes to AI. These are specific to the AI models. These can be the large language models, the NLPs, the VLMs, and these are made of different components. Data pipelines, training procedures are involved in it. Like I mentioned, the training procedures, the environment, the quotient of bias and manipulation of data that is involved, and various parameters and metrics that are used to train these data, and the infrastructure resources, what kind of resources have been used to train these. Those all matter when it comes to an AI solution. And the vulnerabilities, fortunate enough, the Open Web Application Security Project has identified the top 10 vulnerabilities specific to large language model applications. And these vulnerabilities, if you take a look at these in depth, especially the third one, training data poisoning, is something unique to AI solutions and not related to the software solutions that are there. Therefore, there needs to be a solution that is catered to AI solutions to secure the supply chain of AI and detect their vulnerabilities. So the solution that I have proposed, the scope of my solution, because of the diversity of AI products that are available, the models that are available, and the vast scope that is there, I have restricted my scope to open source large language models. And why open source is rather than going to proprietary, because like I said, there is lack of transparency among the developers of these models, and proprietary information is safeguarded and copyrighted and protected. They're not available and accessible in the public domain, as opposed to open source LLMs. You have the documentation available. Now, the challenges that I faced in developing the solution was the complexity of the large language models and what kind of dependencies and the sub dependencies that would involve, especially considering those and then scoping them and defining the boundaries. And then there is scarcity of information and resources. Even though it is open source, the documentation doesn't go in depth as to what kind of components or the dependencies that are there or the sub dependencies that are associated with a particular LLM. And the resources that were used were either the documentation that was available on the GitHub repositories of the open source LLMs, or the research papers that were conducted on their large language models in itself. And these information that is available in the public domain is what was mainly used. To discuss the solution based on the concept map, I'll explain as to the route that I took. So when it comes to the AI bill of materials, the standard or the structure that can be easily customized and can be used for anything out of a software bill of material structure was the SPDX. So I chose the SPDX for the format of the AI bill of material for this purpose. And it was also proposed under the literature review by the researchers that it could be easily customizable. And I have also considered the requirements, the regulatory requirements of the National Telecommunications and Information Authority of US, which gives out a list of components that needs to go into the software bill of materials. I have used the same components in this as well. Leveraging the same concept of the software bill of materials. And then there are for the purpose of the vulnerability detection part, the vulnerability will be detected based on the large language model that is being used and in itself, and based on the bill of material itself, the vulnerabilities will be detected on it. And for the purpose of testing and evaluation, these were the parameters that were used to evaluate the minimum viable product, the quality, the accuracy, and then the vulnerability detection accuracy in itself, and the scores, which I'll be discussing at the conclusion of this presentation. The vulnerability database that I have chosen to use is the National Vulnerability Database, which is an industry renowned and accepted database to hold all the details of vulnerabilities. I'll be extracting specific details to the uh, report that is being generated as the final output for this purpose. To explain about the system architecture briefly, so it's a web application that is being developed. At the presentation tier, the user is presented with a login to the application. A login was incorporated because it was a mandatory requirement by the NTIA to have the authorship and the timestamp involved in the AIBOM generation, so that it is being tracked as to how updated is the AI bill of materials and the vulnerabilities which are detected. Therefore, that was incorporated into it. And then the user is given the opportunity to input the large language model for which they need to extract retrieve the AI bill of materials and identify vulnerabilities against it. And these details of the LLM in itself is extracted from a local database, and the vulnerabilities are then searched from the National Vulnerability Database thereafter, and then it's formatted according to the structure defined and to the output that would be presented to the user. Next phase of the presentation is a demonstration of the solution. I will show you the solution over here. So it's published on GitHub. I have created a login for this purpose. And that was the login screen, and an email ID and a password was picked up. And this would be where the user is allowed to input a large language model name. So I have three models in this, Llama, Bloom, and Falcon. I'll show how it works for each of those models. So when the user enters Llama, this is the output that is displayed. So the SPDX is the standard that I've used. 3.0 is the current standard and the data licensing of it. The name and version of the LLM that's associated, and the release date of it. And the author is the person who's generating this particular AI bill of material and the timestamp that the AI bill of material is being generated. And the dependencies related to the AI solution called Llama, these were the ones which were researched and found in the open source domain, which was included from different sources. And these are the vulnerabilities based on the National Vulnerability Database, which have been extracted via the API that is connecting to it. And I have extracted only the important information, which is the CVE number, the description of it, the brief description, the severity of the vulnerability, and the vulnerability scoring that has been obtained from NVD. The next model that is there is Bloom, another open source large language model. And this is the output for it, the same details, different dependencies associated with that, and the vulnerabilities associated specific to the large language model. And the third large language model specimen is Falcon. And for Falcon, these are the details pertaining to it, the version and release date, and the person who's generating the AI bill of materials, and the dependencies associated with it, and the vulnerabilities as per the NVD database. So that's the demonstration of the solution. Now I will do a walkthrough of the web application code in itself. So I've used the Angular framework and TypeScript language to build this lightweight web application. So This is the format, and I'm extracting these details of the AI bill of materials from a local database. Firebase was used for this purpose. And then after that, for the vulnerabilities, I'm using an API that connects to NVD to extract the particular vulnerabilities of the particular LLM. And this is how it will be displayed in the homepage in itself. And I am using a specific service called AIBOM service, which will be called to retrieve uh, from the homepage components in itself. I'm calling this AIBOM service to extract the specific vulnerabilities and details of this. So the AIBOM services in itself, this is what is used to the API used to get the CVEs from the particular national vulnerability database based on the large language module that is being entered by the user. And then also connection to the Firebase database as well to get the other local AI bill of material details as well. So that is a walkthrough of the code in itself and an explanation. And since Angular framework already has built-in solutions and libraries available, so for the login facility, I'm using their inbuilt on submit functions that are available so that no specific coding has to be written from scratch for that purpose. Coming to the presentation. Based on the results of evaluation. So it was identified the evaluation when it comes to accuracy. The accuracy was identified to be very low. It was about 31%, as I recall. And because the minimum viable product is not capable of negating the false negatives. Therefore, the product needs to be further enhanced to make it capable of negating the false negatives associated with the large language model. And then when it comes to performance, maintainability, and usability, the test which performed performance was 100%. Maintainability was graded as B. The code base was graded as B as to be good. And then usability pass rate was above 80% of the web application. And when it comes to the AI bomb structure, what was evaluated based on the discussions and evaluations of the industry experts who would prefer to have such a solution were consulted, and based on their feedback, what was told was the requirement of a granular level breakdown of the dependencies and their subdependencies would be beneficial to understand the actual structure of the AI solution and their components associated with it, and also identifying the vulnerabilities, the ability to map different vulnerability databases, because without relying on a single source of truth, such as the NVD database, different databases to be mapped. And also identify vulnerabilities for the dependencies and the subdependencies separately, and present those as well, so that it can be evaluated separately. And then, with regard to the scope, without restricting it to just the specimen of three sample models, LLMs, which was also can be expanded for other LLMs, and also other AI specific solutions such as NLPs, VLMs. Those were some of the other propositions which were made to be included as an improvement for the minimum viable product that was displayed. I would like to thank everyone who was involved in assisting me, my supervisor, and the module leader, Mr. Gwanathan Poravi, Mr. Sitira Hevarachi, my supervisor, and all my colleagues and everyone else who assisted me during the course of my um, research. And thank you, everyone, for watching this as well.